Since 2006, Networks has designed and developed an IoT platform called Symphony. This IoT platform manages the infrastructure to allows the whole control and automation of smart facilities in complex technological environment, like, for example, mega yacht, luxury villas, and smart building. So this is the agenda of today, and I want to start with the definition of low critical cyber-physical system. So we identified two types of cyber-physical system: the mission-critical ones and the low-critical ones. In the mission-critical cyber-physical system, the security is central. So we have a stringent time requirement, and we have sensible data inside the system. Also, in the low-critical cyber-physical system, the security is important, but we can relax our time requirements, and the data that flows in the network, in this system, are not so sensible. So we decided to work with the low-critical cyber-physical system. We tried to define some use cases to detect some vulnerabilities inside those systems. For example, we defined a so-called heat remote control. In this use case, we have an IoT environment, and an attacker tried to turn on the heaters in a smart environment. This could lead to unnecessary energy consumption and to a waste of money. But to detect this type of use case, we cannot rely only on strange network pattern, but we have also to define the IoT device status. We have other example like this. For example, we can think about an alarm system that could be turned off when the owner is not in the house, or maybe we can think about the crypto-jacking of the IoT devices. So we can come to a conclusion that we need an enhanced IoT management platform packed with a network traffic analyzer and a flow control platform. Just in case, we have Symphony, that is an IoT platform that that support a broad range of sensor actuators and helps all the types of users to manage and configure their smart environments. So in this picture, you can see the high-level architecture of Symphony, where we have in the center the core data model based on SARF and on sensor teams to define the ontology that is used by Symphony. Upon that, we have some core services that each instances of Symphony have, and are the management of the event and the alarm, and for example, the data storage, where the data is stored on Symphony. And on the top level of the architecture, we have some so-called user-level function that are modules that can be attached to the core Symphony, to the Symphony core, and are, for example, the building manager, the energy manager, and the new module called Anemone that provide the cybersecurity inside Symphony. Anemone is an acronym of Analysis and Monitoring of the Network, and the high-level architecture is shown in this slide. We have at the bottom of the architecture, we have some tools, like for example Symphony and ntopng, that provide to us the real-time traffic analysis. Upon that, we have an adaptation layer that retrieves all the data of the tool and unify them. And on the middle of the architecture, we have some component in order to store the data with some retention logic. We have some decision logic component in order based on rule in order to try to understand what is happening on the network, and we have some actuation logic in order to act or react to the decision taken by decision logic. On top, we have a GUI with different level of complexity, and with this GUI, an end user can view the status of the network. As security operators can manage and intervene on the network, and then we have a cloud GUI in order to show to view the status of each instance of Symfony. So in this slide, I will focus on the adaptation layer and the benefit of using ntopng in our solution. So we, as you know, ntopng provides us the recipe thanks to Martin that explained this in the presentation before. And so we use this REST API to retrieve the data and use them. As you know, the ntopng REST API is divided in several different endpoints that provide us a different set of functionalities. For example, we can retrieve the data of the flow, of the interface, of the alert, and so on. So here, another benefit is the deep interaction of ntopng with the Symfony platform. This is because with ntopng, we have the awareness of the device at network level. If we integrate ntopng with a managed IoT platform, we also have a semantic level awareness of the devices, but the integration between ntopng and Symfony opened the way to a security awareness service in our system. This is because we can cross-check the network data with the semantic level data of Symfony in order to understand if the network traffic has some sense or not. In this case, do you remember the first use case that I proposed in this presentation, the heat remote control and the alarm system? So the network traffic that can make an attacker to this system could be legit at network level. But if we compare this traffic data with the semantic layer, the semantic information, maybe it could be the case that an alarm is switched off when the owner is not at home, or maybe when the owner is on vacation. This could be a problem. So in our solution, we want to make a security automation based by rule. And then in the future can be extended with AI ML models. In this case, in this slide, I propose a simple rule that checks the data, the network data retrieved by ntop, and send another to Symfony, to the Symfony Alert Manager, if the throughput of the network is exceeding a predefined threshold defined by the user. So the next step of our solution is to continue to integrate the ntopng data with Symfony in order to aggregate the data for data visualization to the end user and to the security operators, and to start an AI/ML training with those data. In addition, the ntopng platform is not used only on the product side, but we propose to use it also in some European project. I want to show you an example of this, because in the Robust EU project, we proposed a use case called the Smart Culture. This project aims to dynamic orchestrate the security and fits very well with the anemone concept. To explain a little bit this use case, we have several crops, several fields, all of these fields are equipped with some sensor and some actuators in order to detect the temperature and the humidity on these crops and watering these crops. An attacker can compromise some sensor of some of these crops in order to waste the cultivation. Our objective is to retrieve all the data of the fields and the neighbor fields and compare them with also a third-party weather service in order to understand if some of these IoT devices have been compromised or not. Okay, this is my last slide. If you have a question, I'm happy to answer you. If you have some doubt or you have some interest in this, I leave you my contact so you can contact me, and in case we can discuss also some new work position in our company. Thank you.